Hello everyone, I Raghvendra Singh welcomes you all in the another video. So today we are going to cover a syllabus of engineering mathematics. उसमें भी हम करने वाले हैं क्या? That is discrete mathematics. You all will be aware of discrete mathematics, like we are going to study about permutation, combination and probability, also set theory, mathematical logic, graph theory, and I think it is much similar to if you are studying uh, data structure, then it is just similar to data structure. So many terms used in data structure as it is using in discrete mathematics. Okay, I hope this all is visible. I'm not able to check. So today date is 15th of April 2026. Okay, so let's start. So in the first unit, that is mathematical logic, uh, in this video I will cover each unit, like I have total 5 units, so I will cover one by one unit. Although if I'll make one video, it will cross I think video length will be increased, so I just want to make each one video. So this is unit 1, that is mathematical logic. Mathematical logic. So what are the topics in this logic are statement and notations, connectives, well-formed formulas, truth tables, tautology, equivalence, implication, normal forms, predicates, predicate logic, free and bound variable, rules of interface, consistency, proof and contradiction, automatic theory proving, ATP we are going to do. Okay, so firstly statements and connectives. So basically, what do I mean by logic? So basically, logic is the language of math. It helps us to decide if a statement is true or false without any maybe. Logic language in math, it helps to decide a statement is true or false. It helps to decide if a statement is true or false. Okay, so this is logic. And now well-formed formulas. I will write it in short, WFF. So what are the well-formed formulas? Just logics in the English which are grammatically correct. Grammatically sentence. Okay, these are just nothing. These are the grammatically sentence in English. And what are the truth tables? So basically we all know truth tables. Yes, so we know that truth tables are cheat sheet showing every possible true false outcome for a combined statement. And now next term is tautology. So basically what is tautology? When we will write a logic, then to true false false, then in the last table if there is everything is true, then we will call it as tautology. Okay, and normal forms like domain normal forms, and so now just normal forms. Normal forms, standardized ways to write complex logic. basically standardized. There are some standards to write to write there are some standards to write yes, there are some standards to write complex logic formulas so computer can process them easily. Computer complex logic formulas so that computer can process this easily. Okay, and predicates. Now predicates. So predicate a predicate px predicate is a sentence that contains final number of that contains final finite means definite finite number of variable and becomes a proposition of variable and becomes a proposition. Okay, so px is sentence that contains a finite number of variable and becomes a proposition when specific value are substituted for the variable. When specific value is substituted for the variable okay, I hope you all got this. So now we are going to discuss what is compound statement. Compound statement. A statement is a declarative sentence which is either true or false. Basically, compound sentence is a declarative sentence yes, so declarative sentence which is either true or false. false but cannot be both simultaneously. Okay, this can be true or false, but both not simultaneously. Okay, so this was compound statement. So these are basic some which I have told you in discrete mathematics. One more thing which I noticed while studying this subject is that there is not as such any mathematics calculus. It is very easy, like it's a theoretical kind of, I can say. First time you will study a theory of mathematics, huh? It's very weird, but it's true, and it is very important to the perspective of gates exam. Definitely, I think 4 to 5 marks this subject contains. Okay, so now we are going to study some basic symbols, or which I have discussed already. This is denoted as, this compound statement is denoted as P, Q, or R. Okay, and now we are going to study some symbols which you know most probably already. So what are the symbols? First of all, conjunction, also known as and symbol is like this. Okay, this is symbol. Then disjunction, also known as or, and symbol is like this. Okay, and next is negation. This is also known as not. The symbol is this. Okay, and next is if then. Conditional, next is conditional, also known as if then. This. Okay, then if. Symbol is this. It is called biconditional. Means both side can be true. Okay, so now we will see truth table of each this. So first of all, let's see, this is very important to remember these symbols, because sometimes only symbols will be given and we have to answer on the basis of symbols only. So the questions can be asked, not question, like I'm just defining the logics, that is and. So and the truth table can be, this is P, this is Q, and this is R. So first of all, true, false. In this true, false. Okay, so in and, if one is false, then all will be false. Here both is true, then true, and here will be false. Okay, also you can remember, like one is false, if one false, all false. Okay, and similarly, or if one is true, this for or. Okay, sorry, PQ, this is P and Q. Okay, not only R. So for this, here P or Q. For this, here if one is true, all true. Okay, if one is true, all true. Here true true means true, true false means true, true false true means true. Here false false means this will be false. Okay, yeah. So now for negation, I'm just writing each and everything here because I do not want to draw a table again and again. So this is for negation. Basically negations mean the opposite of the given. Basically this, as you can see, true true, so here will be true, true false, true के बाद false, then false, if false true then true, false true then true. Okay, now if yeah, so here I can remember, here you can remember that if first is true, if first is true, second is false, first is true, second is false, it will be false. Like this is which we need to remember. Okay, first is true, second is false, then it will be false. Now let's discuss if. So यहीं पे discuss if. So if के लिए symbol है this and this. So basically P then, so both. Here I can remember both are same, then it will be same, then as it is, as it is means what I am trying to say is here true true means here will be true, true false, false, false true, false, false false, false. Okay, no, my mistake. Okay, and next, now let's practice some examples. So example number one is negation P and Q or Q. What we have to say, we have to prove that the following proposition is tautology. We have to prove tautology. And what is the condition for tautology? As I told you, for tautology, in the last column, every statement should be true. Okay, so let's begin. So first of all, PQ, here we have to check how many variables are given. PQ, here are only two variables. If R, then we will also write R. So PQ. Now here first is P and Q, P and Q. Then negation of P and Q, negation of P and Q. Then negation of P and Q or Q. Okay, we have to check this column. If this column all is true, then everything should be true. So we will be this, here will be true, true, false, false, true, false, true, false. So P and Q and mean what we have remembered, if one is false, all will be false. So here true, false, false, false. What negation mean? Negation means just opposite of it. So true, here will be false, true, true, true. And now here P and Q means we have this statement. So now we have to or with Q. Or with Q means this to this. And what is the condition of or? If one is true, then all will be true. So here false and true, true, true and false, true, true and true, true, false and true, true. Okay. As I told you that or may, what we used to do is if one is true, then all will be true. Okay. So here as we can see all four variables are true, so we can say hence it is tautology. Okay. And now let's so example number B. And this is the question, we have to prove it. Here one thing which we have to remember that if we first true then false, then it will be false. Okay, remember this. We have to also prove the same tautology. Okay, so first true, true, false, false, true, false, true, false. P and Q. No, sorry, this is or means true, 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 false. Now P, now we have to do with this. Okay. So as I told you, we have to remember this true, then true and false, then it will be false. So here true, true means true, false, true, not true, false. So true, so true, 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 false, false, also true. Okay. So I can say that it is also tautology. Okay. So now let's move on to the next. So there is also one example of contradiction. What was the definition of contradiction? It was if all is false, then it is contradiction. What was the condition of contingency? Contingency means if true, false table, then it will be a contingent. Okay, which you know very well. So right now I'm moving towards normal form. Okay, normal form. So basically, normal form, the standard forms are called standard forms. Basically, standard forms. These are two types. Standard form. These are two types. First is disjunctive, and second is conjunctive. Okay, first is disjunctive and second is conjunctive. So disjunctive normal form, which is also known as D and F. So what is D and F? Can be written as like this, sum. And what is C and F? This is for sum symbol. C and F is product symbol. This is for product. Okay. हाँ, क्वेश्चन कैसे पूछे जाएंगे? क्वेश्चन विल बी आस्क्ड लाइक you have to find conjunction of these variables, these. So we have to remember that conjunctions means this and product. Okay, so now next is elementary product. Elementary product. So basically elementary product. Yes, so elementary product, a product of the variable is a product of variable means variable, product of variable and their negations, product of variable and their negations means what are the variables in the table and the negations. Okay, product of variables and their negation. And this was elementary product and elementary sum. Elementary sum. So basically elementary sum is sum of the variables and their negations. Same here, product here, sum of the variables, sum of the variable and their negation, and their negation. Okay, before this we were studying about propositional logic, which are not enough to express the meaning of sentence. So now we have to study domain and quantifiers. So you all know what are the domain. Basically domain is the domain of a predicate variable is the set of all possible values that may be substituted in place of variables. Set of all possible, basically it is set of all possible values, set of all possible values that can be substituted in place of variable, in place of variable. Okay, and now quantifier. So basically quantifier are the words that refers to quantifies such as sum or all. Refers to quantifies, refers to quantifies such as sum or all and indicate, such as sum or all and indicate how frequently certain statement is true, how frequently certain statement is true. Okay, now here are two types of quantifiers. First is universal quantifier. Universal quantifier means this for all and extensional quantifier means this. Symbol of extensile is this. It means there exist. There exist. Okay. So these were the basic definitions. This was the basic of discrete math. So next in unit 2 we will study about relations. So thanks for watching. Okay.